Hello everyone, welcome to the channel. So today I'm going to show you through some examples how do we simplify mathematical expressions involving powers. I start by reminding you that when we see a variable named x, that means x is of power 1. You have to always remember that. We will use that in the simplifications and throughout the course. Let's look at the first example. We have y equals 3x to the power of 2 minus 5. We want to evaluate y if x is equal to 2. So what we do here, we have to replace x with 2 and see what we get, okay? So y equals 3. Instead of x, we put 2, right? 2 to the power of 2 minus 5. It equals 3 by 2 to the power of 2 is 4 minus 5. It means 12 minus 5, which is 7. Okay? Now let's look at the other example. X to the power of 7 divided by x to the power of 2. From the previous video, you learned that when the bases of the two exponentials are the same, we can write one of them, okay? And for the powers, we simply subtract 7 from 2, right? 7 minus 2, x to the power of 5. So the answer to this simplification question is x to the power of 5. Let's look at the other one. X to the power of 2 multiplied by x to the power of 3. Again, from the previous video, if you look at the previous video, you can see that when we have a multiplication in which the base of the two exponents are the same, we can use one of them, okay, x. And what we do with the exponent is we simply add them together, right? 2 plus 3. So it would be x to the power of 5. Let's look at the other example. X divided by 3 to the power of 2 multiplied by 9x. Okay, so what we do here, when we have a over b to the power of 2, we can write it as a to the power of 2 divided by b to the power of 2, right? So what we can do here, we can write the first parenthesis as x to the power of 2 divided by 3 to the power of 2 multiplied by 9x, right? So it would be x to the power of 2 over 9 multiplied by 9x. Since it is a multiplication, you can see this one is at the, this number 9 is at the denominator, but this number 9 is at denominator. So we can simplify these together. We have x to the power of 2 multiplied by x. I said here that x means x to the power of 1, right? So we have a multiplication. We can use one of the bases and we can add the powers together, be x to the power of 3. So this is our result here. Let's look at this example. x to the power of 7 multiplied by x to the power of 3 divided by x to the power of 6. Here we don't have a problem. We can rewrite this here, x to the power of 6, but here x to the power of 7 multiplied by x to the power of 3, it would be x to the power of 10, right? 7 plus 3, because this is a multiplication. Now we have a division here, so we can write it as x, because both of them have the x as the base. X to the power of 10 minus 6, 4. Now we want to simplify this. Okay, let's forget about this because I don't want to talk about this yet. You want to simplify this expression that you see here, right? Okay, x to the power of 4, y to the power of 3, multiplied by x to the power of 3, y to the power of 5, x to the power of 5, y to the power of 5. First, you can look at this as a whole, and you can see you have a y to the power of 5 in the denominator and 1 to the power of 5 in the denominator. So you can basically eliminate these two together. Then what you get is you have x to the power of 5 here. You have x to the power of 4, y to the power of 3, x to the power of 3, right? So x to the power of 4 multiplied by x to the power of 3 is x to the power of 7. Okay, so we added these two together. Y to the power of 3 stays there, x to the power of 5. Now we have x to the power of 7 divided by x to the power of 5. So we can write it as x to the power of 7 minus 5, 2. And we have y to the power of 3. This is our result of the simplification of this big expression. Let's do this one. We have 2x to the power of 3 plus 5x to the power of 3 divided by 7x to the power of 2. Well, there are different ways of looking at it, but the way I want to do it here is we write the denominator as it is because we don't have anything to simplify here, right? 7x to the power of 2. We have 2x to the power of 3 plus 5x to the power of 3, right? So if we consider this, we have 2x to the power of 3 plus 5x to the power of 3. Totally, we will have 7x to the power of 3, right? Let's say x to the power of 3 is apple. Here we have 2 apples plus 5 apples. It will be 7 apples, right? Now we have 7x to the power of 3 divided by 7x to the power of 2. First, we can simplify this 7 with this 7, right? X to the power of 3 divided by x to the power of 2 is x to the power of 1. 3 minus 2 is 1. Now let's do this example here. Simplify minus 2 over 5 xy to the power of 5 divided by minus 2 over 5 to the power of 3 multiplied by xy. First, you have to look here to see if you have anything common between numerator and denominator, right? But before that, we can do this. Minus 2 to the over 5 to the power of 3 xy I wrote the same. In denominator, I come and distribute this power between these guys inside the parentheses. So it would be minus 2 over 5 to the power of 5. X, y to the power of 5, right? I simply distributed this power between these elements here, okay? Now you can see you have minus 2 over 5 to the power of 5, minus 2 over 5 to the power of 3. So because it's a division, you can write the result as minus 2 over 5 to the power of 5 minus 3, means 2. Here you have xy to the power of 5, xy to the power of 1. So it would be xy to the power of 5 minus 1, 4. So your result would be minus 2 over 5 to the power of 2, because this power is an even number, this minus cannot survive. The result would be 4 over 25 x4 y4. This is our simplified result here. Next, I want to talk about the situations where we have power of power. Let's say we have a to the power of b, then the whole thing goes to another power of c. What we do in this case is we use the base, but we multiply the powers together. A to the power of b multiplied c. For example, 2 to the power of 2 to the power of 3 is 2 to the power of 2 multiplied by 3, or 2 to the power of 6. Let's do this one. X to the power of 5 to the power of 2. You're right, it will be x to the power of 2 multiplied by 5, or 10. Let's do this one. Okay, it would be 2x to the power of 2 to the power of 3 would be x to the power of 6. Y to the power of 3 to the power of 3 would be y to the power of 9. 2 to the power of 2 is 4, x to the power of 2, y to the power of 2 to the power of 2, y to the power of 4. So if we look here, you can simplify this 2 with this 4 becomes 2, right? So we have a 2 here. X to the power of 2, y4, x6, y9. So we can write it as 1 over 2 multiplied by x to the power of 6 divided by x to the power of 2 is x to the power of 4. Y to the power of 9 divided by y to the power of 4 is y to the power of 5. So our results would be 1 over 2 x4 y5. How about this one? 3x to the power of 2 to the power of 3. Okay, so first you have to remember you have to distribute this power between anything inside the parentheses. It would be 3 to the power of 3 multiplied by x2 to the power of 3. So it would be 9x to the power of 6. Let's do this one. This is not like a power of powers, but it's just an example that shows you how we can use the rules that we learned to simplify the expressions. So we have these expressions that we want to simplify. First, we have to see what's the impact of this minus sign before this parenthesis, okay? So I write the first one again, x2 plus 2y plus 3. If we want to basically apply this minus sign inside this parenthesis, it would become like minus 4x to the power of 2. We have a minus here, another minus here, so the result would be plus 2y, right? If we can simplify it further, we have 1x to the power of 2 minus 4x to the power of 2, right? So it would be 1 minus 4x to the power of 2. If we have 2y, we have 2y, so the result would be 2y plus 2y would be 4y. Like 2 apples plus 2 apples is 4 apples, right? So we did this one, we did this one, we did this one, and we did this one. We have a plus 3 left here, so I put it back. So it would be 1 minus 4 is minus 3x to the power of 2 plus 4y plus 3. So this is the simplified expression that we have here. So the key point to remember here is that if you want to learn these very important mathematical techniques in simplifying expressions, or to be comfortable to work with the powers and with the variables, you have to do a lot of examples and a lot of practice. You can look at any textbook that you have, and you can simplify. You can try to practice them. The more you do, the easier it will get for you. And this is, I mean, these techniques are something that you have to use for a long time, especially if you go to an engineering field or other technical fields in the college or in the university. These should be very simple for you. If you have any questions, you can leave it in the comments. I'll try to look at all the comments and to answer all the questions. Thank you for watching. Please subscribe to the channel. We'll talk to you in another video very soon.